If you like my dad's videos, please subscribe to QA Insights channel.
Okay, I think we can start, Jakub. So thanks, Jakub, for joining. So before we get started, I would like to say a few words about our sponsor. Our sponsor is, as usual, Redline 13. So if you want to run high scale load testing using JMeter, please check it out, redline13.com. So hi, Jakub. Welcome to Performance Engineers Clubhouse. How are you doing?
Hey, thanks for having me here. I'm good. The weather is nice today.
Thank you. I think you're joining from Poland, correct?
Yes,
Okay,
exactly.
cool.
That's in
So
Central Europe.
got it. So how far the Ukraine from your country?
We're neighbors actually. So all the refugees, like most of the refugees, are welcome in Poland. So if if they're fleeing from Ukraine, they are immediately attended on the border, and they are actually there are no like refugees camps. We just take them home. So yeah, the situation is pretty tense right now, but we are hoping that this war is going to resolve soon.
Yeah, hope. Yeah, we are hoping it will end soon. And thoughts and prayers for your neighbor country folks. So actually, more we have Indian students are also there studying medicines. Most of the Indian students in Ukraine, yeah, they are eventually they are vacating the country. Cool. Uh, so this week's topic, Jacob. So you mentioned performance test design using APM and observability. So could you please give some limelight? So before that, you can just give some intro, and then you can get into the topic.
Of course, yeah. So hey, I'm Jacob. In Poland, you may hear this as Kuba, so that's a common name in Poland. I work as a performance engineer for one of the biggest bank in Northern Europe. Currently, I lead the team of four engineers for performance engineers with a focus on some core banking platform. And yeah, I recently started sharing my knowledge on the internet, knowing seeing what may be missing and what you guys can benefit from, from what I've learned over the years that I've also learned in my career. Yeah, so my say career in the IT was mostly related to the SRE, performance testing, and performance engineering.
Sure. Yeah. Thanks, Jacob. So can we directly go to the topic? So what is the gist of this topic? So what are you going to share?
Okay, so performance testing is the APM and observability. The design of a test, because when I often review the code and the test that the other testers are designing, they may be too synthetic. I mean, they often do not represent the full picture of what they see on the production system. So there would be some discrepancy between what you're seeing on a test against what is actually happening on a live system. And then the only difference that you are seeing is that it's caused by the syntheticity of a test that that they've created, and against the organic end users that have some say other behaviors, other inputs than what you are seeing than what you have on a test that you have designed. So I think it's gonna address this discrepancy. How can we mitigate that, and what actually are the factors that we can be looking at, and what are the KPIs we are missing when only applying the synthetic end users, like the load generation via the synthetic users against the applications.
So simply put, say we have a application in production. That is the performance we might not know unless it is going to the live audience. But in the staging environment, we get some performance. But in real world, we don't see the actual performance, whatever we experience in our stage environment. So, right. So we are going to bridge the gap between the production, the live performance with the whatever the experiments we have done.
Exactly. Yes. So, and this is so, there are a few things and few factors we can look at from the current whatever is currently on the production system and take them in to replicate during our tests to make sure we simulate the same behavior as we're going to have on the production system. So I think
before,
this.
So before that, you used the term called synthetic, right? So can you please give some explanation about what is synthetic in this context?
Okay, yeah. In this context, a synthetic user is just an average user that was probably created by some test data generation process, which represents an average user of a system. Right? This is a standard practice that I've seen so far in my career. That whenever you have some staging environment, you request for some number of users that you plan to migrate, that you plan to test with, and they would have a common number of items assigned. I don't know, common like values assigned to certain tables, and the only condition that they can fulfill is that you can actually use them for your load generator, and the same for the wait times between their actions. So the wait times are mostly static between each of a call, and this is like something that's not really seen in the production system, right? So, for example, you have some between those actions in your test script, you can put some values, some wait times of a few seconds, of some milliseconds, depends on the on what you have recorded. But then, when you look at your APM, some real-time user monitoring, and check whatever the users are actually doing on the production system, you see those numbers are way higher, and the wait times are also higher than what you're seeing on than what you're generating using your performance tests.
So basically, it is not a real user. It's just some automation script we will create to simulate that stuff, right? That steps.
Exactly. Yes. So the main difference between those, the real user and the synthetic user are actually of course the actions that they invoke. So you cannot simulate the entire actions of the user unless your application is pretty straightforward and pretty simple, that you can, I don't know, regenerate the production load using the application logs. This is something that's doable, but extremely complex.
So how frequent that script will run in the environment?
So we're talking about generating the entire, let's say, peak load of the users. So at least once per release that you have to rerun those. Okay. So the thing is, and I think that's worth mentioning here. This representation of the production load is important because you should know what to expect actually when you go live, right? If you see some discrepancy, you'll find yourself not struggling and battling. Why are you seeing different like hardware utilization models, like hardware some different different utilization, especially on the memory footprints, if you have your timing is not right. And yeah, this is one of the things that I think, and that is my opinion, should be closely monitored to make sure that you can actually guarantee that your system is going to perform for all the users, and not just the average ones, and not just for say not just for for the user, for the advanced user that already know your product, right? This is something that I think we are missing when generating the scripts by just simply recording them and then replaying all the actions we have in some run book for the test.
Got it. So I use Neuralink. So in Neuralink, we have a dedicated space where you can write some JavaScript, and then you can create that traffic from this using synthetic user. So similarly, all APM tools has that feature. Dynatrace and other tools also has that feature. But as a performance engineer, it's just a one-time activity. We just focus on a couple of scenarios. We just put it there, and then it will keep running for every build or every release or every changes. So that is how we configured.
Yes. So, and we have also the NFRs, right? So they are mainly, they're given in terms of a throughput, in terms of the latency and errors. These are the most most common NFRs or the SLAs you'll have as a performance engineer, right? So when you run a test, when you want to achieve a certain throughput, you play around with the number of users you can generate on basically number of threads of your load generator, and you also play around with the pacing of your user. So after each iteration, you can add some small pause between you start each iteration, right? So these are the two factors, and this I think applies to all of the performance testing tools. That you can easily shape your throughput against the application, but this also comes at a cost, and I think that's worth mentioning here, that you do not exactly simulate the entire user base. Like if you only play with the number, with the pacing, and just slightly amending the number of threads that you have to generate the desired load, you're maybe missing an important factor, which is the number of concurrent users currently logged into the system. And this is something that that is often omitted, and it's something that is often neglected, as there is a cost to a session per user, right? So whenever we log into the application, we create some session, and this session has to be maintained by the web application until the session is finished, right? So if we have a script that does the login, does some action, and then there's a log out or not, depends on your test design, and it does it in a very short period of time, then you only utilize this chunk of memory, which is often heavy. Like the session data is something that is extremely costly on the application side. If you have this if you have your session for too short span of time, then your memory footprint on the application would be different. Like, because if you have, for example, if you can generate, let's say, your 1000 TPS, 1000 transactions per second, using 200 threads, right? Then you're limiting the memory utilization of your application to only those 200 threads, and they represent actually just the 200 concurrent user on the system, right? In reality, it's gonna be like shaped differently. So you're gonna have thousands of users, and then each of them is gonna hit your application every second or two. Depends on their focus. Like even right now, when we are talking over this application, not all of you do any actions right now, right? So most of you guys are just listening there. Some of you will be asking questions, raising hands, but this does not happen like all the time, right? And I think it's also one of the important factors of of performance testing, to make sure that the profile we are generating, so the load profile we are generating, is also accurate. So the vendors of load generation tools, they know that, and you'll often see that they are being priced based on the virtual users, right? So they also expect you, like the vendors of those applications, expect you to pay for the license depends on how many users you want to actually simulate. So and I know that's a cost saving stuff. So you can pack some few more TPS, few more requests on the same thread, and you're meeting all the NFRs because you can actually generate the throughput you want. But then on the application side, you will see a different footprint of the usage, and this is especially hard for the applications that use the garbage collected the automated garbage collection algorithm, like Java or C#, because if they utilize this memory, it also produces some cost on the application side to maintain it for the duration of the object lifespan.
Yeah, you brought up a good point, Jacob, regarding the using the threads to achieve some throughput, right? So we can achieve using 10 threads, we can achieve say 100 TPS. If the application is performing good, even we can use 5 threads to simulate that 100 TPS, right? So in that case,
Yes.
we are missing there is a lot of gap between the production performance and how we are testing it, right?
Yes,
This
exactly.
question is often comes in all the community groups. This I mean, if you search, people will be asking, okay, how can I do some 10,000 users? How can I do some 1 lakh or 1 million threads, right? Because we have to pay money to the vendor, or if you are using open source, we need to provision that infrastructure. Otherwise, we don't get that number of actual threads, right? So that is why we have to deep dive into that open workload model and closed workload model, and we have to understand the architecture of our application, right? Then only we can design our tests properly. Otherwise, we'll be testing something else, and we will get some other performance in production.
Mm-hmm. Yes. So the tools I found very useful to help me shape the behavior of the transactions are really the real-time user monitoring, because then I can see the scope of the session of the real users, right? So I can also verify for certain services if they take longer, for example, the wait time after, like between the next call, is also going to be longer from the perspective of the user, especially if they are like time consuming. So let's say the service duration is going to take like 4 seconds or 7 seconds. Then you can expect the next call from the end user is also going to be similar to the response times, because they already expecting sorry, they're already expecting the service to be slow, so they are not like waiting for it all the time. And I think that's one of the things that we are meeting. Of course, the cost of the thread itself on our architecture is not that high, so it's something that the load generators are doing quite okay from our side. So we can easily generate thousands of threads on a machine, and it doesn't like blink. And of course, it depends on your architectural requirements. And if you are, for example, using a browser-based application, and your tests are like the True Client or Selenium or whatever browser client you have, then of course this calls for some optimization on your side. So one thing to address that is really now focusing on going back and focusing what is actually the purpose of your performance tests, right? It is not just to assure that the service is responding in some given time frames, but the general goal of performance engineering really is to make sure that the user experience is okay, right? This is so we are measuring the response times of the service. We are making sure that the reliability of the service is acceptable. But these all are just the requirements to make sure that the end user is going to be happy with your service, right? So going back to the test design, and especially for the browser-based applications, you don't really have to simulate the entire user base as if they were like sitting in front of a computer and then clicking stuff on the browser. I think that's something that is not widely known or maybe utilized because it is costly in terms of the development. But the users you have really like they are gonna open the mobile phone they're gonna open the web browser on the PC. What you should care about is their experience, meaning how long it takes for them to render a page, whether they see it's been responsive or not, how interactive it is, along with the load. So there are two goals really. You need to make sure that your application is meeting. First, that it responds, and the other one is with the load, right? It's not necessarily that you have to generate your entire load using those browsers, because this as soon as you join a company with a fair complexity and you want to run simulation of millions of customers throughout the day, you will soon find out that you don't have a supportive infrastructure to generate this load from on your own, and then it's gonna call for this optimizations, as you say, like for like lowering the think times, lowering the pacing, and like making sure that you can generate the throughput with some higher with some lower number of your clients. The stuff that I've seen and I've heard people are doing to mitigate that is to have a few browser users that really do the whole rendering, they do all the calls like as if the application would, as if the end user would do, and then on the background they also have the users, the vast majority of users generated over the protocols. So just by raw threads, and they generate the load on the background. So this gives you a way to verify the user experience. So you have those browser users that generate the load for you, and they check the response times, they check how long it takes to render a page, along with load that you actually anticipate from the system. This, of course, this comes at a cost. So this costs you maintenance of the two separate scripts for doing the same operation, but it's a big saver on the test infrastructure that you require to do when you want to go on some higher tier and so high complexity applications, especially for the ones that you really need millions of users generating the load on your against the application you're running.
Got it. So the strategy is like, say we have an application in, say, Facebook or Amazon like websites, single page applications. So it doesn't make any sense to simulate like, say, 1,000 browser view users or 10,000 browser view users. Instead, we have to distribute the load. So backend we have to slam with loads of load, and from the UI we have to simulate only the certain percentage, right? So a couple of browsers. That's
yes.
we have to blend, mix and match the load, right?
Exactly. So the theory behind it is the rendering cost is fixed for most of the services. The cost of the rendering and the duration of the rendering is going to be fixed. So the difference between making a call and rendering the result is only going to be dependent on how fast your service can reply. This is for the most of the service. There are, of course, some services that you do some streaming, of the call, do some, multiple asynchronous calls to fetch all the different data for your application. But in most of the cases, this cost is fixed, and and of course you need to simulate it. You want to make sure that your application can actually handle that. So hence, you have to give some 5% maybe of the users, or even less. It depends on your user base, and just a certain amount of users to be rendering that, as with that in mind, that you have some users that generating the proper load on the backend, right? So this from the application side, from your application, the load profile doesn't change, right? Because the service is still accepting the same number of calls. It's still generating the proper responses. It's still because it doesn't matter whether you're running from the browser or from a protocol. The application is still bound to respond in the same manner. So and then you can also capture the full scope, so full frames of your renders, and make sure that your end user is gonna be happy, even if your application is under high load or under some stress.
That's correct. Yeah, a similar exercise I have done in the past, around 4 years ago, I guess, using TrueClient and WebHTTP HTML. So usually what I did was, I named the transaction, for example, TrueClient transaction and WebHTTP HTML, both in a similar fashion, and then I just find the difference between the TrueClient and the WebHTTP HTML. So WebHTTP HTML is for web services, and TrueClient is for the browser. So we just find a difference, so we can identify easily what it is taking, what time is taking to render the page. So that exercise I have done in the past. So whatever you mentioned is similar, very similar.
Yes, because you have to remember that the cost of the browser itself, it only costs your load generator, like the CPU cycle. It doesn't generate any load against your application, really, apart from what you would have on the protocol based, so on a script based test. Right.
Correct.
The only difference is that you pay the price for rendering, which is only dependent. And I'm talking here about most of the applications. It's not all of them. There are some exceptions to that. For most of the applications, it's going to be a fixed cost, and it's going to be only as fast as your end applications of as the end user CPU would be.
Correct.
Right.
That's correct.
And this, a proper, and I think it's stated somewhere in the documentation of those of Selenium and for a TrueClient, that you need at least one core dedicated for the browser for it to be representative, right? So you need to dedicate as at least a single core of your load generator for the browser to make sure that nothing is disturbing those the results that you're generating, right? So if you, for example, have want to simulate 60 users from the browser from using TrueClient or Selenium, you're gonna need 60 cores from your load generators to make sure they are actually representing the state of your end user.
Correct. And also
otherwise
the performance is very subjective, right? Because I will have Intel i5 processor, and end user might have a Apple M1 processor. So for him, the browser will render very fast, and also other factors like internet speed. Say they have fiber optics, and I have only the dedicated 1 Gbps line. Again, other people will have only 10 Mbps line, right? So a lot of factors influence the end user's performance when it comes to browser.
Yes, that's true. So when we're talking about the let's say transfer, this is, I think, is something that is a separate topic, really.
Correct.
For the transfer, because you can measure the end-to-end timings also based on the protocol. So it's that it's you can virtualize your network for the test, and I also love the NeoCortex new service. They do the mobile phones. I think you've used that too.
Yes.
They they do the real devices. So you can use their phones, and it simulates your load with the real network. I think it's actually a neat idea.
Correct. And also it depends on the
Yeah.
browser, right? Chrome again resource hungry, and if you're using very lightweight browser, again you will get some better performance. So it is really subjective, and a lot of factors are there. It influences.
Yes. So, but we assume, at least I assume, that the rendering cost is going to be fixed on whatever I want to have, and this is it's going to be derivative of the service response times, and I still want to measure that. But generating the load of your millions of users or thousands even, it's going to be too costly to maintain from your architecture side, because soon you're going to end up asking for the same infrastructure as your entire user base have. Like, this is something that really doesn't come cheap. So some of the steps, some steps to optimize this have to be taken to make sure your tests are not actually too costly.
That's correct. Yes, it's very expensive. Browser testing is very expensive, resource intensive, and because I tried that in JMeter also. I tried using Selenium WebDriver in JMeter, and a true client also. Again, we will not be able to put more load because it's very resource hungry. We need very powerful machines to simulate that.
Yeah.
So that's why we come up with some number. So usually what percentage you recommend? Okay, this percentage could be say for the browser and this percentage should be backend. So do you have any percentage split?
I mean, okay, so really to have a representative sample, you need to at least depends on your throughput really, because I think this is also something that you have to what you have to take in mind. That the more the merrier. So that depends. This really depends on the on your requirements for the application. If you have, for example, a dedicated host, dedicated machine that you can generate 20 to 50 users, I think that's sufficient for any application to make sure you measure the right stuff, right? Because you can still distribute and you can still distinguish between the service response times and render times, right? This is something that you can still capture, and it is still a expensive architecture. Talking about 50 even to 100 cores that you have to dedicate for the machine, right? This is still a way higher than I think any company is budgeting for. But when you really get into the point when you need to simulate the 100 concurrent users, you probably know what you're doing, right?
That's correct. Yes, yes, that's correct. So usually, yeah, I went with 10 percentage of the load to the browser and 90 percentage to the backend. But I have seen in the forum where I have read about only 1 percentage will be suffice for the browser and 99 percentage should be on the backend. Yeah, it varies. Depends on the what you want to test and how you want to test.
I think the sampling matters here. And the throughput you're actually generating with those with those clients, right? Because the
Correct.
more samples you're gonna have, the more detailed your reports are gonna look like, right?
That's correct.
So yeah, that's
Okay,
I
let
think
us
that's
take some questions from the audience. So please raise your hand if you have any questions, so that yeah, we can continue the discussion. So if you are new to this platform, please, there is a hand icon. Please touch that so that I will approve to be in the stage. Okay, we have Sid.
Oh, hi, Jacob. Hi,
Hi,
Naveen.
hi Sid. How are you?
Yeah, good, good. How are you? Yeah.
Good.
Uh,
Yes, Sid.
yeah, thanks, Jacob, for a good topic you brought it. So I do have two or three questions. So before starting my questions, I would like to starting from this first. So you do mention you're working kind of SRE performance engineering. So how do you correlate like SRE kind of more into production support. So how do you correlate like performance engineering and SRE together? That is first question. Then I'll follow up my second two questions.
Okay, I mentioned SRE because this was my previous role in the same company. So I was
Okay,
talking about
sorry.
the history. I've moved from SRE right now to performance engineering.
Got it. Thanks for that. And so I was thinking you are doing both SRE performance engineering. It's kind of sound like new. So I just asked this
No,
question.
no, no.
Yeah. And the second question comes like uh, you're talking about synthetic user, right? So you really call synthetic user as a true client user, which you added a portion of your user load to your actual user load, or is it a separate entity?
No,
Synthetic.
it's a separate entity. So I mean, when I talk about the synthetic user, I'm thinking about the results of of the standard development process of a test. So that you open a page and do some like start the recording of your actions. With the firm with the setup round book that you have. So let's say you have some requirements for like utilizing specific service, and this is your scenario, let's say entire test scenario, and this is actually a synthetic steps because when you like when you look at the load from the monitoring from the browser monitoring you have, like if you have it, assuming you have it on your application side, you will see that those actions would differ, right? So of the real user, I'm talking about the synthetic, meaning, hey, I've clicked that here. I want to, let's say, add a new item to my shopping list. I don't know. This is gonna be just an example, right? So you log in. Like the scenario would be that you log into the service. You like search for the specific item on the list, and you add it to the chart to the cart in the application. Probably do some checkout and log out, right? This is what I call a synthetic user, meaning it doesn't really represent what the actual user would do, right? Because in a like in the real life scenario, your user would open like this web page, browse, hover around, read the news first, right? It's gonna check what's new, probably check some discounts. It's gonna then look for the specific item, maybe not even look for it, maybe it's gonna go through the sort all the items by the price, and then select the cheapest, and then check it out, right?
True,
So
true.
those
But
actions.
my,
Good.
sorry to interrupt, Jacob. So my question is like, how do you incorporate that synthetic user in your load test or your load model?
Okay, so this is defined by the by checking the statistics of the real time user monitoring, right? So the you can check the sessions. So whatever like the average users have been doing on and the actions they have performed, and this is what you can like now. You can just aggregate the steps of the most commonly used on the session, and then you can shape your testing scenario based on those actions. And I think that the most maybe the actions itself are not that important to like of course they're important to make sure that you're invoking them in some of your test scenarios. But what I think would be the most important in this case would be the timings and the time that they take between those actions, and specifically, how long do they keep their session opened?
Yep, that will cover an aspect of initial part of performance testing phases when we gather the requirements. So, if at all, if you get a chance, if you're analyzing the prod logs and you're designing the load models, yeah, I do agree the whatever the points you cover. So, what are the key rules and how much think times? So that generally, most of this nowadays, everybody is not keeping their real fixed think time. Anyway, we are going to put there is a percentage of think time to simulate in real users that will cover. So as part of that, so there is a synthetic monitoring is a APM which covers on the real user. But my question still here is what the point I didn't get here is how do we get that? Is it the practice we are already doing as part of performance engineering, or there is a separate things we need to consider to implement this synthetic user?
So Sid, so I use Neuralink. I already mentioned this. So in Neuralink, I have written a simple JavaScript where only the critical transactions, right? For example,
Okay.
add to cart or searching for the string, right? So those things I have just embedded, and then it will proactively send some traffic, and then it will display the metrics in the Neuralink dashboard itself.
Okay.
So there are different types available. I mean, if you want to simulate browser or only just API, so it is up to you what you want to do using that synthetic stuff.
Okay. It's as part of our load model, right?
It could be, it is a part of load model, but it will just go and keep it. I mean, I don't maintain that every now and then. It keeps running.
Got it.
Unless it is failing, I don't touch that.
So will it be in like in our lower environments or is
No,
it?
in production, I'm talking on production.
Got it. Got it. So in the APMs, they you call RUM, real user monitoring, and
Yeah, that real user monitor is different. Synthetic monitor is different.
okay.
So synthetic means basically it's a machine, right? It's some robot you can think of like that.
Okay.
So it will automatically send some business transaction, and then it will make sure, okay, this page is up and running, this transaction is up and running, and it will keep sending the signals.
Got it. Got it. And yeah, thanks for clarifying that, Naveen. And one more thing I would like to bring up, like, so even I work like a similar like you, Jacob. I work for the banking project, so where we have a separate entity, like session management is a separate app to mitigate all these things from the application perspective. And one more point. So when you talk about the number of threads from which we are simulating from the tool, it only valid that kind of test when you are only concentrating about throughput. That's what I feeling. You can elaborate on further here.
Okay, so the number of threads is not only the representation of your throughput, but also the number of concurrent users you have on a system, right? So if you have the session management, I think you mentioned as a separate entity, you'd also be you'll see the different behavior of it when you try and keep the more sessions active on your system. It's the impact, of course, may not be great. Let's say it's not something that's gonna be, it's a fundamentally different than you see on a production, but the difference will be distinguishable.
Yeah,
So
because it will mitigate the memory footprint. Like so, whatever the sessions are not active, it will maybe
exactly.
answer it and it will garbage collect it.
Exactly. And we're talking about the sessions that can last for 30 minutes. It's not something that you typically have on the production, because I also use myself applications that I keep open for 30 minutes, for an hour. I keep them refreshing, they're just popping up there. And this is not something that's typically done on the say during our performance test, right?
Yep.
So one of the things, of course, you can keep the session running and never log out, right? That's one way to mitigate this and to address those sessions not being open. But then again, if we're talking about the applications that use the garbage collected models, it's like their existence in the memory is also cost us CPU cycles, right? Every time we do a garbage collection, it also has to check for the specific memory block, can it be released or not, right? It's still an allocated block of memory that we have to maintain on the system.
Yeah. So basically, what mitigate? I mean, reduce the number of virtual users and create virtual connections more with those threads, like multi-threading. Right?
Still come again?
So what you suggest for to mitigate this from the tool perspective, use minimum number of threads and create as many as possible like production. That's what you're saying?
I mean, it's just as much thread as I can. So the thread from my perspective would be a real user, meaning the user is gonna take some pauses, perhaps a coffee break between those calls, something that I can like see and verify, seeing from the APM tools, right? So if I can like verify that how many users like on average are taking, or take up some distribution of those users, right? You can also check the distributions of the call of the wait times between the calls,
Yeah.
and then add that on top of your test to make sure that actually your load is representing the something that you can that you can expect on the production system.
So what is the point here? So like what it was meant for, to maintain to maintain the sufficient sessions, or to achieve the, so two things here: number of threads, number of virtual users is different, and number of load. Like five
Mhm.
users can create 5 hits per second code. They can create 10 hits per second code, right? It's a speed of the activity they are doing.
I'm not sure I get this last question of yours. The like if you make sure if you make sure the one thread's gonna be representing a single user, you already cover a major factor that is often not mentioned in the NFRs, which is number of concurrent users logged into the system. Right, unless your like your SLAs mention that, hey, we want to maintain this number of users and they will be doing like this number of requests, and then of course you have to make sure that you're actually simulating the same. But having those two variables is not only the throughput, not only the response time, but also how many users I can actually accept to the system concurrently. This is something is like, at least by looking at the practices that I've seen, is not something that is taken into account.
True, true. But that number of connections will be defined, obviously, number of connections at web server level. So, yeah, I got your point.
Yeah, no, it's not just the number of connections like that you have, because the thread can have like the machine itself can maintain like plenty of connections. And I think of course this number of connections to the server, meaning I'm talking about the HTTP connections. So I'm talking about this single call. This defines your throughput, right?
Yes.
So essentially, the number of connections would be somewhat corresponding to the throughput you're generating, but also the footprint on the memory and footprint of the application is also defined by the number of your threads. And I see that as like one of the things that the vendors are actually limiting. So for example, in the load runner, you can have a licensing for the n number of users, let's say 500 or 2500, and this is something they see like as one of the limited factor. And then if you look at the requirements for your system, saying, hey, I want to achieve now 2500 TPS, let's say, but I can only generate 100 users, right? So what do I do? Yeah, of course, I'm going to limit the pacing, or I'm going to limit the think times, so the throughput is going to match, right? Everyone is happy, like we're meeting the throughput, the service is responding fine, but then the release comes on the production, and we are reporting some memory leaks, because suddenly we are like, of course you're going to see some reports of memory leak, but then you will soon learn that, hey, we actually have way more sessions on the application than there were during the test.
So, what you're suggesting, like do production like as similar to as production. right?
Yes, exactly.
See, it depends on the number of connections. That's a mantra. How many connections we are expecting? The same connection we have to simulate. Not just spinning up the threads will not help
Yeah,
us.
like Jacob said. So tools, there is a tool constraint, right? Like paid tools like JMeter, you don't have the limit on threads and users. But if you're using like tools like Loadrunner, other tool New Lake, so they have license base, right?
Yes, in that case, yeah, we are going with the TPS, not by the users. Yeah, we can only simulate the how many transactions per second we can
Yeah,
spin up,
load in
simulate,
terms of yep.
not the number of v users, not the number of actual users.
Yes.
That's what next week I am scheduling another topic, open versus closed workload model. So that topic will clear many of the doubts.
Yeah, thanks, Jacob. It was nice speaking to you, and sorry I took much time. Let others have it.
That's okay. We love the questions. Thanks, Sid.
Hi Eldad, thanks for joining. Hi Rajesh. Yeah, please
Hey,
go ahead.
how you doing? How you doing, Jacob? Great talk, great topic to bring up. I think observability is a major part of performance engineering and site reliability as well. They're two intertwined in a way. I would like to bring up another issue that is also intertwined with not just the workload model, but uh, in general everything that we just discussed, the synthetic users and the thread. A thread-based load model or rate-based workload model. I think that one topic that also needs to be taken into account is the the Internet of Human versus the Internet of Things. So if you look at the Internet of Humans, it's very interesting because the human flow is like, I want to see this dashboard. Okay, so it looks like it's just one tiny thing, but this dashboard is like 8 requests. So it's very naive to just send those 8 requests in a sequence, but in real life, the browser sends them asynchronously. It sends them all together in pretty much one shot because it sends the first request and then immediately sends the second request. It doesn't hang for a response in the interim. However, in JMeter, for example, if you have this thread group and you have like 8 requests one after another, they would be sequentially, they would be synchronous. Okay, so you send a request, you wait for a response. That could take for who knows, 2 seconds, 3 seconds, if your system sucks, but it could happen. So if you try to emulate that in JMeter, for example, you're going to have to use a thread per request, and that is extremely costly. And you're going to run into pretty much the similar trouble that you talked about, that browsers are very costly. So this is one problem that you're going to find in the Internet of Humans. In the Internet of Things, the Internet of Things is about machines, right? So machines, they don't go for coffee breaks. They don't take times off. They're pretty much steady state. So it's kind of easier to predict how they're going to behave, but they can generate an extremely high load because they can send, requests one after another. Well, it could be requests, it could be something else because it's not always HTTP. HTTP is not very efficient in the Internet of Things. You're going to try something like MQTT or lightweight M2M or the other machine-to-machine protocols, but they're going to be very fast, robust, and heavy. So you're going to have two different kinds of challenges. One is that you're going to have very high loads when you deal with the Internet of Things. And with the Internet of Humans, you're going to have a high load actually occurring on the agent side, on the client side, or the synthetic client side. And it's going to be very costly for you to generate that load. So I would really like to get your reaction to this. If you think that the Internet of Humans versus the Internet of Things is really intertwined in this discussion.
Obviously, thanks for bringing up this point. First of all, to get your attention on the asynchronous calls, it's not supported by default by JMeter, but you can use Groovy async calls, so you can create an executor service from the Java concurrent library to have the calls asynchronously invoked in a single thread. I think that's
Yeah,
something.
I think the problem with that is that you're not going to have very fine, a fine grained level of report if you send them in a single groovy sampler, because the report will show this groovy sampler and it will not go into the details. So you're going to have to do a lot of workarounds if you want to really understand what happened. It's just one thing. One way I looked at it, there is a plugin by BlazeMeter that can parallel everything that is underneath it. So if you imagine you plunge this sampler, and anything that underneath it is going to be a thread. If you have 8 things underneath it, it's going to be 8 threads. That's extremely heavy. But that's one way I could see, and that's going to be very transparent if you use it in a distributed mode. But go ahead.
Yeah. Okay. Speaking of Internet of Machines, this one is the easiest to really to simulate, because the scheduling of all the systems. How often they're going to ping you, and this works like a clock. The task of simulating the load coming from the machines, and it's just purely driven by them, so there is no external factor. This works like a scheduler really, and this you can have those calls, and they can be like extremely synthetic, and I see no problem with that. Meaning you can even pack the stuff probably in a few threads, simulating all the loads, and even representing the whole, like I guess in context of the machines, they're not gonna have a session or anything like corresponding to that. So each of the calls is going to be unique, and each of the call that it generates is going to be say like stateless basically. I don't think this, like, I find really myself, I find the Internet of Humans more challenging to simulate really than the Internet of Machines. Unless I'm missing something, but I've never actually done that. So I did some like integration testing. So with the mainframe to the system, like mainframe to mainframe testing, some other like say protocols, but I've never simulated a load coming like from the machines. But I guess the task of it should not be like extremely hard, especially when we're talking about just the machines, because when you think about it, it's gonna have a like request or some cron job, like whatever you're gonna call it, any scheduler that's gonna send a request every n seconds or n minutes, right? And most probably it's not gonna be a like in the scope of the session, it's gonna be a single separate call using some authentication. So in this case, I think a simulation of the load would be just a few thread groups with like just shaping your throughput really, with no context of say concurrent users, right? Because this we as humans need this scope here, right? The machines can handle all the stuff by themselves. So they just request some specific information. They have some access key. They are accessing that. So probably communication over the interface, over the API, is sufficient for them, right? So they're requesting for specific information. Hey, get me this, and then followed by like post me this. And this is from the machine perspective. They don't have to wait. They don't have to analyze stuff like for n seconds. The wait times between the calls are gonna be way lower than the human can even react to.
I agree. Yeah.
Yeah, thank you, Jacob. Hi, Rajesh. Please go ahead.
Hi Navin, thanks for this wonderful session again. I just have a quick question because we're running out of time. I'll just directly go into question now. Jacob, like you said that you are working in SRE, right? And you're currently working on performance engineering stuff. So we just Even like we are planning to move to SRE. So can you please help us like what exactly, I mean, what are the challenges and essentials that you need to move to your team from performance testing engineering to the SRE kind of environment?
The best resource on SRE I found was the SRE book that's available on internet. I think this is gotta be this is the source of information that you'll be mostly interested in, because like SRE is for the reliability of the system and of the entire architecture and infrastructure, right? So we're talking about making sure that your system doesn't fail under any condition. Performance engineering, on the other hand, performance testing focus on the performance of your application and the performance of your particular system, right? So when talking about the SRE, it's not just your application itself, but it's also maintenance of your and the supports of your CI/CD process. It's supporting of your, say, current state of your production system. It's actually, I think the core idea of the SRE is focusing on 50% on development of new stuff, that either your team or the other teams will use. So making sure the say development flow, so the entire software development lifecycle is shorter. So automating stuff that that take up time by other teams. Yeah, I think it's both, like both roles are great to really, like, to really shine and to really develop yourself. And this depends solely on your, like, say, application needs. So what would be the priority for you. I'm not saying they're interchangeable or like the stuff, but I was actually, like, moved because the application that I work with required some more attention specifically towards the performance.
Okay, thanks, Jacob. Thank you for your inputs.
Thank you, Rajesh. Hi, Pawan.
Yeah, hi, Naveen.
Yeah,
Is my
we have
audio?
a very less time. Yeah, please keep your question short. Probably you can touch base with Jacob offline if you have any other questions.
Oh, okay. So, yeah, I mean, then probably I think I'll touch base with him offline. Then.
Sure, yeah.
Thank you.
Thank you. Thank you, everyone. So this week's been wonderful session again, as usual. So next week, we are going to talk about open versus closed workload model. So Jacob, do you have any inputs for us to begin our journey to continue designing using APM and observability? Any references or books you refer?
First, the requirement would be to learn what are your options to see what the users are doing, and this is really towards, like, learning how your APM tools are really consuming and how are they monitoring your users. I think that's the first, and then you'll have some ideas around it. So once you learn, how to track, the actions of the users, what are the actual operations that they are doing, this will give you some ideas and starting point to shape your test properly, right? As soon as you'll find the difference between your scripts and what the actual users are doing on the system, you'll have some ideas and improvement. So the first step would be really to look into your APM tools, your observability, review the application logs, see what is the difference between the users you have on the production system and the users you are generating from your side. I think that's the first thing I would be looking at, because this is where I started my journey really with this, and it's helping, like, understanding my application as well, right? So this is something, and of course the users, which is what we care about the most.
Yeah, thank you, Jacob. So how can we reach you if you have any questions?
I'm on LinkedIn, so you can find me on LinkedIn, I don't think I have any other tool, like, available. So you can find me on LinkedIn. It's yeah, under the same name.
Sure. Thank you. Thank you, everyone. So before we sign off, yeah, this week's sponsor is Redline 13. So please check it out, redline13.com, if you want to run high-scale load testing. And next week, again, we will come up with a new topic. Again, we are going to discuss in deep, actually, how you can plan your workload model. So please join. And this session is being recorded. It is available in Clubhouse for your future reference. Thank you, everyone. Have a good weekend ahead. Thank you. See you soon.
Thank you.
Bye.
If you like my dad's videos, please subscribe to QA Insights channel.